All right, we're going to take a look today at segments in triangles. Okay, lots of words today. Mid-segment, perpendicular bisector, the converse of that, angle bisector and its converse. We're going to understand those. And we're going to do a lot of solving today. Okay, smiley face. Okay. All right. A mid-segment, and there's going to be a lot of writing today. You pause when you need to, okay? A mid-segment of a triangle is a segment connecting the midpoints of two sides of the triangle. So example here, a mid-segment would be GR, okay? It's connecting the midpoints of two sides, so you'll notice that it divides the sides that it intersects right there. Those are congruent, and then these are also congruent. So GR is an example of a mid-segment. The triangle midsegment theorem says if a triangle joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. So, if G is the midpoint of NT, which it is, and R is the midpoint of TI, which it is, what we're saying is that GR is now parallel to NI, and however much Ni is, GR is half of that. So if this were 10, that would be 5, 20, 10, 100, 50, whatever. So they're parallel and it's half the length. So let's take a look and label some things. I'll do the first couple for you and then you'll try and figure out some on your own. So let's see. Say right here we have ER is labeled as ER is 5. Okay. And EM is 4, and RM is 7. So how much is GO? Well, GO is this, and it's across from the 7. It's parallel to that, so it's just double. Okay. TO is parallel to RE, so that's 10, and GT is parallel to ME, so that's 8. Like I said, GT is parallel to ME. TO is parallel to RE doesn't matter, and GORM. Alright? So far, so bueno. Take a second, pause the video, you try this one on your own. Pause the video now. Okay, hopefully you noticed as you were doing this one worked in the reverse direction. So AC is this whole thing, so that's 12, so FD is half of that, so FD is 6. CE is 10, so BF is half of that, so that's 5. BD, right here, that's across from AE, which is 8, so that's 4. All right, and BD is parallel to AE. BF is parallel to EC, and DF is parallel to AC. All right, moving right along. Find the value of X. Okay, so let's take a look. We have a mid-segment. We know that because it's labeled. So this 2X is half of that. So that's what I write. 2X is 1/2 of 80, which means 2X is 40. So X is 20. Here, 4 is 1/2 of this. Or you could think of this. If you know this is 4, then this has to be 8. So then you could just say X minus 2 equals 8. So X equals 10. No problemo. All right? Equidistant. We need to understand what that word means. Equidistant. If a point is equidistant from two objects, it's the same distance. Equal distance. That's all it means. That's all it means. So point P is equidistant from points A and B because PA is congruent to PB. Equidistant, equal distance, same distance away. Perpendicular bisector. A perpendicular bisector of a segment is a segment line ray that is perpendicular to, so it hits it at a 90-degree angle, to the segment at its midpoints. That's important, so it's midpoint also. Okay, so PM is a perpendicular bisector of of AB, and AM is equal to MB. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment that is equidistant from the endpoints, then it is equidistant from the endpoints of the segment. Okay? If PM is a perpendicular bisector of AB, then PA and PB are the same. Okay? That's all we're saying is that if this is a perpendicular bisector, then this point is equidistant from the endpoints of the segment. The converse here, if a point is equidistant from the endpoints, then it is on the perpendicular bisector of the segment. So if you know that these are congruent, then you automatically know that this is a perpendicular bisector, and so we have that relationship. So it works in both directions. So, practice. Assume that the vertical line is a perpendicular bisector of the base of the triangle. Solve for x and y. So if this is perpendicular, that means that's also perpendicular. So 3y minus 3 is that angle, and that's got to be equal to 90. Add 3 to both sides, and y equals, let's see, 93, so that's 31. Okay? Here, if it's a perpendicular bisector, it means those two are congruent. So 5x minus 6 equals 2x plus 9. So we get x equals, what is it? Pause and do it if you don't know, but what is it? What is it? What is it? 5. Okay? If you're not getting these, pause the video. Try to work them out algebraically, and if you're still not getting them, you need to ask a question. Distance from a point to a line. The distance from a point to a line is the length of the perpendicular segment from the point on the line. Distance and length are the same thing. Okay? The distance from D to AC is the length of the perpendicular segment from D to AC. So distance and length. We just need to understand that those are the same. An angle bisector is a ray that divides an angle into two congruent sides. So an example here, QS is the angle bisector of PQR, and then since PQS and SQR are marked congruent. Angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So if this point right here is on the angle bisector, then that is congruent to that. That's all we're saying. The converse is that if a point in the interior of an angle is equidistant from the sides, so if we tell you that this point is equidistant from here to here, then that point is on the angle bisector, so it also has that relationship. So some practice. Find the measure of ABC. So ABC, that's the whole thing. Important to understand. We're looking for the whole thing, the whole enchilada. And now I want enchiladas. It's an angle bisector, so find x. So if this is x plus 8, well, so is this. And ABC is that, so we know that 2x plus 16, which is just x plus 8 times 2, equals 4x minus 4. So x has to equal, let's see, we get 20, 2x, 10. That doesn't answer the question, though. They want to know what's the measure of ABC. We plug that 10 back in, and the measure of angle ABC is 36. Okay? All right. A median. A median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. So it connects a vertex to a midpoint. That's what a median does. Okay? Median. So let's see how we could use this. If we tell you that this is a median, and we want to solve for x, this equation here, or that expression, we don't even need that one. Okay? It has nothing to do with this. Just extra information. No likey. But these two, it's a median, so that's congruent to that. So x plus 4 equals 2x minus 13, and x equals 17. Here, altitude. Altitude is the height. Okay, altitude can be different depending on the triangle. If it's an acute triangle, it can be inside the triangle. For an obtuse triangle, it might be outside. Or for a right triangle, it's actually one of the sides. The altitude lands in a 90-degree angle. So find AC if BD is an altitude. Okay, so find AC if BD is an altitude. Well, the only thing we can solve for right now, we can't set these to equal to each other. The only thing we know is that 3x plus 9 equals 90. So 3x equals 81, so x equals 27. Okay? Then we want to find AC. Well, that's the whole thing. So this is 27, and then this is 2 times 27, which is 54, minus 7, which is 47. Okay? And then we're going to add those two. So AC equals 74. All right? That's it for the notes, guys. It's that easy. If you didn't get any of the practice questions that I did, if I went too fast, try and watch the video again, or just make a star, make a note of it, and make sure you ask for help there. All right? Good times. Always a blast. See you next time.